The Dayton pilot plant was established to conduct the technology transfer of the devulcanization technology from China to North America, including verification testing at the Akron Rubber Development Lab, the preparation of material safety data sheets so the chemical compounds and the finished product could be transported and handled, and for the processing adjustments to automate the process to make it safe and to test the worker conditions to ensure that worker safety could be maintained. The Dayton pilot plant was engineered, designed, and constructed over the course of 3 months and was fully controlled by a PLC logic controller so that the plant, other than loading the materials at the front end, could be operated by a single person at the controls. The PLC also allowed us to vary time periods, mixing temperatures to test out the process. With the exception of loading raw materials at the front end and removing finished product at the back end, the Dayton pilot plant was fully automated and was controlled by the PLC. All processes were timed and measured, including the loading of the raw materials, the monitoring of the temperature, the injection of the specialty devulcanization chemicals, and the cooling of the material and subsequent delivery into the finished goods hopper. The Dayton pilot plant was operated for 2 years and completed its program, including the following. We tested alternative crumb rubber sources and types to see which was the best material for devulcanization. We completed the independent testing of the percent of devulcanization of AMR and RU rubber. We completed the air quality and worker safety studies, as well as material safety documentation for the technologies and the products that we'll be using. We optimized the process to maximize the properties and consistency of the end product, and we completed development of conventional and alternative applications for the use of devulcanized rubber master batch in various products. The engineering and design work that was done at the Dayton facility also positioned us for the building of the full production lines, which we are currently undertaking. The only modifications from the systems installed in Dayton will be that the material will be moved by pneumatic systems rather than augers, and the raw materials in terms of the activator will be coming directly from a mixer where we're producing that material on site, and will be piped to the process rather than stored in barrels and heated as it was in Dayton. The PLC process control logic will essentially be the same. There'll be minor modifications, but the engineering for the full control automation of the system is in place and can be reused on our new facilities. In addition to the testing that was done on the materials at the Dayton pilot plant, samples that were devulcanized in Dayton have subsequently been tested after being stored in conditions where the material was frozen through to being exposed to high temperatures and humidity, and results have shown that the material has retained its devulcanization conditions even after a period of 10 years and still exhibited a full complete devulcanization, thus meaning that we will never have a question of shelf life on our material. It's a very stable product. In conjunction with the technology transfer, we also conducted testing of the devulcanized rubber master batch in various products, including essentially 100% devulcanized rubber in a safety cone base, and ratios of from 10 to 50% devulcanized rubber in tread stock material on a series of tires that were manufactured and tested to determine how the material performed. We did not have any failures with respect to the use of the rubber. The product we sell will be bagged in bags and sold to manufacturers as devulcanized rubber master batch.